In this example, what we're going to be doing is factoring this polynomial f of x into linear factors, right? And so linear factors look something like this: x minus k, where k is a numeric value. Okay, so we're going to have multiple of these guys to factor this guy right here. And just one little cool thing to know about in algebra is that the highest power tells us how many factors we should have. So really, we should actually end up with 3 factors, and we'll get to that, I think, in example 4 or 5, talking about the theorem, the fundamental theorem of algebra, and that the factors tells us, or the degree tells us how many factors there are, but then that also tells us how many roots there are, both real and complex. But I'm getting ahead of myself right now. So let's just go ahead and start off what we know. Okay. So if -7 is a 0, then that's very helpful information, because that means when we do synthetic division, we know that the remainder is going to be 0. And that's going to help us find the other factor. So I'm already banking that this is going to be 0. Because when it says that something is a 0, then that means that the remainder theorem says that we better get 0 with synthetic division. So let's go ahead and try that bad boy. So we're going to drop down the 8, multiply, and that's a 14. And that right there is, was that -98? And add that was that 15, -15, and then multiply that, we'll get 105, and voila, we get 0. Okay, so the reason that is helpful to us is that now these numbers right here are going to help us give us our next, our other factors now, or at least our next polynomial. So watch this. So this right here, it means that is the factor x plus 7. Okay. These guys mean now this is 8x squared plus 14x minus 15. You say, how'd you know all that? Because you always start with 1 degree less. So since we did all of these guys, and now we did our synthetic division, you're always going to start with our next degree, which is 2. So a degree of 2, a degree of 1, and then a degree of 0. So this you could think of this as x to the power of 0. So the question is, are all of these linear? No, right? Like this is a quadratic right here. These are not all linear factors. This is a linear factor, but now we have to factor this guy so it's linear. So now let's go back to what we learned a few chapters ago about just factoring polynomials. And let's see, how should we factor this one? I think this one I'm just going to do my little diamond thing. There's all kinds of ways that you can do that. 8 times -15 is a -120. And then 14 on the bottom. So 2 numbers that multiply and give us -120 and add to get 14. 20 and 5, 20 and 6, right? 20 and 6 gives us 120, by a -120, and a positive 14, so -6. So watch this, what I do here. I'm going to just work with this guy right now. That's all I'm going to work with. I'm going to leave my 8x squared. But now I'm going to rewrite 14x, I'm going to rewrite that using these guys. So I'm going to do plus 20x minus 6x. Do you see how I just rewrote 14x? That's all I'm doing right there. It's the same thing. It is still 14x. I'm just rewriting it and then drop down -15. So I just want you to realize that I haven't changed the problem, just the way it looks, but it's essentially the same problem. So now if we group the first 2 and then group the second 2, you're going to find something really neat that always happens. Factor out the GCF. What is it? 4x. So then inside we'll have 2x plus 5. And then here was a -3 times 2x plus 5. See it? And this should always happen. What's inside of the parentheses should always be the same. So I'm going to factor that out. Each of these 2 have the exact same factor. So if I factor that out, 2x plus 5, then what do I have left? I have 4x left, and I have -3. So what I just did right now is I took 8x squared plus 14x minus 15, and I rewrote that as two linear factors. So now if I just drop this bad boy down, x plus 7, voila. I've just satisfied the problem. It said to write our polynomial as linear factors, and look, they're all linear because x has a power of 1, power of 1, power of 1. They're all linear, and there it is.